Window functions allow you to perform, for each row in some underlying query, a calculation against a subset of related rows, and we call that subset of related rows the window. They're kind of like correlated subqueries used in your select clause, but they have some other really nice advantages. In this video, we're going to be looking at 3 window functions that relate to ranking. I'll demonstrate these 3 ranking window functions by looking at the film table. So we'll start by selecting from film. And for each film, we want to select the title, the length, and I'm now going to introduce the 3 different functions. The first one is called row number. So row number is a function that will operate over, and then in parentheses now, we have the opportunity to specify what's called the window that the function will operate over. In this case, I'm just going to be specifying a window that consists of all the rows from the film table ordered by length. And I'll do the same thing now, but introducing the other 2 functions as well. So one of the functions that I wanted to introduce is called rank, and the other function that I want to introduce is called dense rank. Let's run this query, and then I'll explain things a little bit more. Our query here is first selecting all of the rows from the film table. We don't have any where, group by, or having clauses. We're just selecting all rows from the film table. And for every film, we want to select the title, and we want to select the length of the film, and for every film, we want to calculate what's called a row number. And that row number is calculated over a window. So what's the deal with this window thing? Well, basically, you can think of every row from the underlying query, so in this case, that's every row from the film table, gets ordered by its length, and then the row number function is run over those rows. So you can imagine that there was some sort of virtual table that was created in the background, all of the rows from the film table. Imagine that virtual table is ordered by length, and then each row is assigned a number, 1, 2, 3 in sequential order, the row number essentially. And if we look at our output, that's what's happened here. We have row number starting at 1 and going all the way to 1000. Every row in the film table got assigned a row number. So for every row in the underlying query, this window function called row number was run, and the window was defined simply to be all of the rows ordered by length. Rank behaves a similar way in the way it interacts with the window, but what rank has done is for the window that it's operating on, so for all of the rows from the film table, rank has assigned a rank based on that length. The shortest film when you order by length has a length of 0, that got a rank of 1. The next 5 films, which all have a length of 46 minutes, got assigned the rank 2, because each of those films is the second longest if you ordered the films by length ascending. The next longest films are 47 minutes in length, and what they got assigned was the rank of 7. Well, what rank has done is behind the scenes it's kept account of the films. So even though all those films that got a rank of 2 had the same length, behind the scenes the rank function kept count. So we have 2, 3, 4, 5, 6, 7. Dense rank, on the other hand, behaves a little bit more like you might have expected rank to behave. So a film with a length of 0, that gets the rank of 1 because it's the shortest film. The next longest films are 46 minutes in length. They all get scored with a rank of 2. The next longest films are 47 minutes, and they all get a rank of 3, and so on. So there's a fairly nuanced and subtle difference between how rank and dense rank behave. When you're defining the window that these window functions operate on, you can also introduce a partition keyword. And what partition does is has the effect of dividing the rows into groups. And then that window function only acts on one window partition at a time. So using the partition keyword lets you apply functions within even smaller subgroups. We're restricting the window. Let me demonstrate this now by introducing the partition keyword here. And we need to partition by some column, so I'm going to partition by the rating column, and I'll do that for each of these functions. Okay, let's run this. Let's have a look at the results. Scrolling to the top, And what I'll introduce as well is the actual rating itself, so you can see that when we're looking at the results. Okay, so what's happened here? The window has now been partitioned, and the window function will only operate on one window at a time. So you can think now, behind the scenes, what's happened is a virtual table has been created consisting of all the ratings that are G ordered by length. And now the row number function will operate first over that window. So let's have a look at the results. We've got rating G, row number 1, and these are all ordered by length, you can see as well. If we keep scrolling down, then we'll see something quite interesting when we're done with all the films that have a rating that's G. So the row number has progressed sequentially up to row number 178. But then what happens when we get to the films that have a PG rating, the row number starts over again. And that's because we've started a new window. So the row number function simply operates over one window at a time. We're partitioning by rating, so essentially for each rating, a new group or a new virtual table is created, ordered by length, and that becomes the window that the function can see and operates over. And so if we look at the films that have a PG rating, their row numbering again starts at 1, and continues sequentially all the way up through the current window until we start on a new window, and because we're partitioning by rating, the next window is PG-13, and again, the row number function starts over again and operates only on that window. So what are these window functions useful for? Well, it turns out a lot of different things. Consider if I asked you to return me the 3 films with the shortest length, and also to include ties. So if we just clean this query back up, if we get rid of our partitions, and we run this and we had a look at the results, if I asked you to return me the 3 shortest films with ties, what I'm essentially asking you for is to return me all these films here, 6 films. And that's because there are several films that have an equal length, a length of 46 minutes. If I asked you to just return me the top 3 and you just did it using the approach that you know, where you ordered the results and then used the limit keyword, you would have to somewhat arbitrarily pick and choose which of the films with a length of 46 minutes you would want. Using window functions, we don't have to do that. What we can do instead is simply keep all those films, filter the results by the films that have a rank that's less than or equal to 3. So what we'll actually do is embed this as a table subquery. So we'll say select star from, and we'll make all of this a table subquery. From film, that's part of this table subquery, we'll alias that as t, and then what we simply want to do now is say where the rank is less than or equal to 3. So what we've now obtained is the top 3 films with the shortest length, including ties. In terms of other applications for window functions, there's actually a lot. And in the coming videos, you're going to see how you can deal with calculating running total type questions more efficiently with window functions, and also how you can deal with those next and previous type questions more efficiently than compared to using subqueries.